Hey there, everybody. The purpose of this video is to make the page big enough to be legible. Is to get you some solutions to this 2 average quiz. We're trying to see if there's differences in levels of education between cops in City 1 and City 2, and that's average years of schooling. So we're testing mu. And we've got City A and City B. This is a pretty, I apologize for the kind of, it's kind of an antiseptic quiz, but average, years of education of cops in City A. Let's make that subscripted so it looks prettier. Education may be spelled correctly. And this is going to be exactly the same, except it's going to be the average years of education of cops in City B. We're going to see if there's, we tested for a difference? I've forgotten. Now let me look real quick. Is there a difference? Yes, so we are seeing if there is a difference between, let's insert a does not equal sign. If we have it, we do. Is there a difference between these 2 parameters, or does there appear to be a difference between these 2 parameters? I don't know. Let's find out. Type 1 error would be saying there is a difference in educational average when, you know what, we can just verbally say this. I'm going to keep screwing the typing up. I'm typing horribly today. You say that there is a difference in the average ages when in fact there isn't. And a type 2 is you say there isn't when in fact there is. I'll let you decide which type is worse. This is actually kind of fun since education is often tied to salary because it's tied to promotion. So anyway, you can decide budgetary might be an issue in this one. Kind of fun to talk about. But regardless, we are going to use the t-distribution because we got 2 averages to talk about. Test statistic and p-value are going to come straight out of the t-test, which we have to turn on and run. It's a 2 sample. We are going to run some, it looks like we have stats. Yeah, we have stats. So City A, we've got an average years of education is 15 with a standard deviation of 2. And we've got 38 of them, it looks like. City B's got 14 years, pretty close. Standard deviation of 1.5, good. Whoops, 1.5, enter. And we've got how many of them? 30? 30 from B. All right, good. We are just seeing if there's a difference. Nice strong test. I'm not going to bother pulling data because I have no idea if the variances are equal or not. So there's that little curve again. Ooh, pretty small p-value, 2% with a test statistic of about 2.4 standard deviations. So we've got about 2.4 standard deviations, which gives us a p-value of about 2%, which means Fisher would tell us, go back and take a look. Is there really a difference? Maybe, I don't know. Right now, at the outset of this test, it appears that the levels of education are different between the cops in cities, A and B. It doesn't even recognize my typing. Looks like we got different education levels, which could yield a type 1 error, but of course we've trained you well about errors now. Because just because there's a statistically significant difference does not mean there's a practically significant one. There could be absolutely no difference between 15 and 14, if indeed they're close to 15 and 14. Maybe the test just identified it as such because. So anyway, hopefully that helped you get some of the mechanics of the test down, and we'll catch you in class.